So this is lecture 7 on network topology, unit 5 EC3251 circuit analysis. This is lecture 7. So here I am discussing link and loop analysis, problem 2. Okay, link and loop analysis, problem 2. Okay, so here in this question they have asked evaluate I1 in the circuit shown in the figure. Evaluate I1, we need to find I1. I1 is mentioned here. I1 is mentioned here, so we need to find I1. So I try to keep this I1 in any one of the link so that I can use it. Okay, so I need to find I1. First of all, I am going to draw a graph. So for drawing the graph, I need to consider a number of nodes. But in the question, it is not necessary to draw a graph. But let me show you how to draw a graph. Okay, so we have node 1, 2, 3, 4, 5, 6. So totally 6 nodes we have. So I am going to draw all the nodes. So 1, 2, 3, 4, 5 and 6. So for each and every element I need to replace it with line segment. 1, 2, 3, 4, 5, 6, 7, 8. There are totally 8 branches or 8 elements. So 8 line segments are drawn to draw a tree. Okay, to draw a graph. So it is a graph, not a tree. It is a graph. So next I need to draw a tree. So in order to do that, I am going to clear all this. Let me clear all this. So I am going to draw a tree. The same number of nodes will be there. So 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and last one is 6. So I drawn all. Okay, so while drawing the tree, I need to make sure all the voltage sources should be in a tree. Okay, all the voltage sources should be in a tree. So 30 volt source I am going to draw. It is in a tree. And we have 19 volt, that should be in a tree. We have 25 volt, that should be in a tree. And while drawing the tree, there should not be any closure path, but I need to connect all the nodes to be connected. So this I am going to consider as a link because I need to find that current. Okay, this I am going to consider as a tree. This is a twig in a tree. So I completed a tree. There is no closure path in it. Okay, it is my tree. And the branches which is not available in the tree and which is available in the graph, I am going to call it as co-tree. So this is not available in a tree. So I am drawing the co-tree using dotted lines. So all the co-trees are drawn using dotted lines. 4 ampere source. See, all the current sources should be kept in the co-tree. All the current sources should be kept in the co-tree. So I kept in the co-tree. So the dotted lines represent co-tree. Okay, this is one of the link in the co-tree. Okay, so totally, so 1, 2, 3, 4, 5. 5 twigs we have. Total number of nodes is equal to 6. The number of twigs is equal to n minus 1, which is 6 minus 1, which is equal to 5. It means the number of branches which I am going to draw in a tree will be 1 less than number of nodes. The branch of a tree we call it as twig. The branch of tree we call it as twig. Okay, and there are 3 branches in the co-tree. We'll name the branches of the co-tree as link. Branches of co-tree are written as link. Okay, so I have drawn tree and co-tree. Tree and co-tree are drawn. So next I need to assume the current directions. Okay, so I'll redraw the tree and mention the current directions one by one. So listen carefully. 1, 2, 3, 4, 5, 6. So this should be in a tree. This should be in a tree. Okay, I'll erase this. This should be in a tree. This should be in a tree. And this should be in a tree. I am going to consider only one link at a time. First I am going to consider this link. So current flowing through that is I1. So how the current will flow? It will flow all the way around this loop. So this is the current I1 which is flowing around the loop. Flowing around the loop. So I name it as I1. So write clearly I1 is the current which is flowing around the loop. Okay. Next I am going to consider the another link. I'll draw that. 3, 4, 5 and 6. So now I am considering this link. So go and check the diagram. So that link belongs to this 4 ampere current. That is in downward direction. That is in downward direction. So in this direction 4 ampere current will flow. So I'll redraw that. So in this direction, downward direction, the current has to flow. It is my 4 ampere current. So that I have drawn based on this link. Based on this link, we have a closure path here. Okay, we have a closure path here. So in that closure path only I can draw the current. The last one I'll draw here. 1, 2, 3, 4, 5, 6. So connect it, connect all this. Okay, so we have the last link. Okay, what is that link? Just go and check. So that is this 1.5 I1, which is in upward direction. Is flowing in this direction in this loop. Okay, clockwise there. So I will consider that. So 1.5 I1 is a current. So now I am going to combine all these 3 diagrams together and I have drawn here. All the 3 diagrams together and drawn here. Okay, so outer loop is I1. So we have one more middle loop 4 amperes and then 1.5 I1. 1.5 I1. We have only one unknown which is I1. So I can apply KVL to the outer loop. So KVL to be applied to the output loop. Before that I will be mentioning all the voltages. So it is my 30 volt and here we have 5 ohms. And rest I will just look at and write. And 19 volt. So plus minus 19 volt. And here we have 2 ohms, 4 ohms, and then 25 volt. So minus plus 25 volt. So I hope I covered everything. So everything to be considered. Okay, just consider only the outer loop I1. Okay, so only this I am considering, only the outer loop. So if I start from here, it will be plus 30 because the current I1 entering positive, leaving negative. So plus 30 is written. Okay, plus 30 is written. And then the current I1 is flowing through this. So if I assume the polarity based on the current direction, I can write 5I1 plus 5I1. And then we have minus 19 volt because the current I1 is entering negative, leaving positive. So minus 19. Okay, and then so here in this 2 ohms I have 4 ampere current flowing in this direction, and I1 is also flowing in the same direction. So the total current will be I1 plus 4. So 2 times I1 plus 4 will be the voltage, plus 2 times I1 plus 4. It is in the same direction as I1. Okay, and then through the 4 ohm we have 3 currents. One is 4 ampere current, another one is I1 in the same direction, and 1.5 I1 is a current flowing in the opposite direction. 1.5 I1 is a current which is flowing in the opposite direction. So 4 plus I1 minus 1.5 I1. So I1 plus 4 minus 1.5 I1 multiplied by total resistance is 4. Total resistance is 4. And then the same current I1 is entering positive and leaving negative of 25 volts. So plus 25 equal to 0. Okay, so I have only one unknown and one equation. One unknown and one equation. So 30 minus 19 plus 25. Okay, and then we have 2 times 4, 8. And we have 4 times 4, 16. 4 times 4, 16. So everything to be considered for writing. Okay, so 30 plus 25. What do we get? 30 plus 25. 30, 40, 55 minus 19 will be 36. Plus 5I1 plus 2I1 plus 2 4s are 8. 4I1. 4 times 1.5 which is minus 6I1 plus 4 times 4 it is 16 equal to 0. So we have minus 6 plus 4 plus 2 plus 6I1 minus 6I1 I can cancel. We have plus 5I1. Okay, so 36 can be taken to the right hand side, is minus 36 minus 8 minus 16 which will be minus 60. So I1 will be equal to minus 60 by 5 which is minus 12 amperes. Minus 12 amperes. Okay. So that is the question. In the question they asked only I1, so we found I1. I1 is equal to minus 12. Thank you.